Heritage 2019. Hasil karya mahasiswa Prodi Arsitektur, diantaranya teknologi bangunan, perancangan ruang dalam, dan studio perancangan arsitektur. Program studi teknik sipil. Program studi ini memiliki fasilitas 5 laboratorium, yaitu Laboratorium Ilmu Ukur Tanah, Laboratorium Mekanika Tanah, Laboratorium Beton, Laboratorium Perkerasan Jalan, Laboratorium Hidrolika, serta memiliki tempat uji kompetensi lembaga sertifikasi profesi yang menyelenggarakan 2 skema LSP, yaitu skema okupasi ahli pengawas pekerjaan struktur bangunan dan skema okupasi ahli muda pengukuran jalan. Prodi Teknik Sipil memiliki ruang sekretariat Prodi Teknik Sipil serta ruang dosen Prodi Teknik Sipil. Pengabdian kepada masyarakat, himpunan mahasiswa sipil juga berperan aktif dalam membangun infrastruktur di Desa Lewisadeng Bogor bersama Ikasila. Beberapa seminar di program studi teknik sipil diantaranya Seminar Konstruksi Indonesia di JI Expo Jakarta tahun 2018, penyuluhan rumah aman bencana oleh para dosen Prodi Teknik Sipil yang diselenggarakan oleh BPBD DKI Jakarta, sejumlah prestasi kemahasiswaan program studi teknik sipil, antara lain juara 1 Lomba Tingkat Nasional Earthquakes Resistant Building Design Competition di Universitas Pelita Harapan tahun 2018, 7 besar nasional Lomba Kompetensi Jembatan Indonesia KJI kategori Jembatan Baja yang diselenggarakan oleh Kemenristek Dikti di Makassar tahun 2019. Program studi teknik mesin. Program studi ini memiliki fasilitas 7 laboratorium, yaitu Laboratorium Perancangan dan Bedah Produk sebagai tempat uji kompetensi lembaga sertifikasi profesi dengan skema perancangan mekanik umum yang terdapat di ruang Teknobis, Laboratorium CNC, Laboratorium Prestasi Mesin, Laboratorium Metalurgi Fisik, Laboratorium Mekatronika, Laboratorium Fenomena Dasar Mesin, Laboratorium Energi Baru Terbarukan EduTechnoPark, menggunakan sistem biodigester dan pyolisis, serta sistem pemanfaatan air wudhu untuk menyiram taman dan tanaman kearifan nasional. Program studi teknik mesin memiliki ruang sekretariat Prodi Teknik Mesin serta ruang dosen Prodi Teknik Mesin. Inilah beberapa prestasi kemahasiswaan Fakultas Teknik Mesin, antara lain meraih silver medal dan gold medal pada kompetisi Regional Education and Student Product Exhibition Respex periode 2018 hingga 2019 di Port Dickson Politeknik Malaysia. Meraih gold medal pada International Competition Students Creativity on Technology and Culture ICOSTATEC 2019 Jakarta, serta meraih juara 2 di ajang Lomba Inovasi Sumber Energi tingkat nasional IEIC Indonesian Energy Innovation Challenge 2019 di Makassar. Program studi teknik informatika. Program studi ini memiliki fasilitas 4 laboratorium, yaitu Laboratorium Network and Security, juga sebagai tempat uji kompetensi Network Designer, Laboratorium Penelitian, Laboratorium Artificial Intelligence dan Komputasi, Laboratorium Software Engineering, dan tempat uji kompetensi Lembaga Sertifikasi Profesi Software Engineer. Prodi Teknik Informatika memiliki ruang sekretariat Prodi Teknik Informatika serta ruang dosen Prodi Teknik Informatika. Inilah beberapa pengabdian kepada masyarakat program studi teknik informatika, antara lain Internet Sehat untuk Ibu Kader Posyandu Budi Harapan Depok tahun 2017, workshop sistem keuangan desa di Kecamatan Babakan Kabupaten Cirebon untuk meningkatkan akuntabilitas laporan keuangan desa Juli 2018. Peningkatan pangsa pasar untuk UMKM Batik Cirebon tahun 2018. Edukasi digital marketing Pondok Petir Depok tahun 2020. Pengabdian kepada masyarakat mengenai rainwater harvesting system untuk mendukung pengembangan potensi Pulau Pramuka Juli 2017. Serangkaian beberapa kegiatan mahasiswa Prodi Teknik Informatika, ikuti pameran produk IT dan panitia lomba robot tahun 2018, studi kunjungan ke bisnis startup pada tahun 2018 dan 2019, serta teknik Pancasila desa ke berbagai daerah di Indonesia. Prestasi mahasiswa Prodi Teknik Informatika, finalis tingkat nasional pada Technocorner 2020 Internet of Things Development Competition di UGM Jogja, Maret 2020. Raih gold medal dan juara 2 pada International Competition Student Creativity in Technology and Culture (ICOSTATEC 2019) di Universitas Pancasila pada tahun 2019. Program studi Teknik Industri. Program studi ini memiliki fasilitas 4 laboratorium, yaitu Laboratorium Statistik dan Aplikasi, Laboratorium Manajemen Industri dan Teknik, Laboratorium Sistem Produksi, Laboratorium Perancangan Sistem Kerja, dan Ergonomi. Program studi Teknik Industri memiliki ruang sekretariat Prodi Teknik Industri serta ruang dosen Prodi Teknik Industri. Prestasi kemahasiswaan program studi Teknik Industri antara lain juara 2 Entrepreneur Day Universitas Pancasila 2018 yang diselenggarakan oleh CEDC Universitas Pancasila. Kegiatan kemahasiswaan Prodi Teknik Industri di antaranya IESC, kontes keilmuan teknik industri, latihan software pro model, AutoCAD, Microsoft Office, Industrial Mini Project (IMP), mengembangkan kreativitas mahasiswa dalam memodifikasi barang bekas menjadi barang yang memiliki nilai guna. Program studi teknik elektro. Program studi ini memiliki fasilitas 9 laboratorium, yaitu Laboratorium Fisika, Laboratorium Telekomunikasi, Laboratorium Sistem Kendali, Laboratorium Digital, Laboratorium Elektronika, Laboratorium Pengukur Listrik dan Instrumentasi, Laboratorium Komputer, Penelitian, Laboratorium tempat uji kompetensi lembaga sertifikasi profesi, skema fiber optik dan program logic control. Ruang fungsional lain seperti ruang dosen, ruang rapat elektro, ruang administrasi pelayanan fakultas dan elektro, ruang diskusi dan baca elektro, ruang sekretariat Forte Regional 3, ruang kelas kuliah dengan kapasitas 30 hingga 70 mahasiswa. Inilah karya tugas akhir dan ruang karya ilmiah program studi teknik elektro. Program studi teknik elektro juga pernah mengikuti rangkaian kegiatan seperti robotik, menggelar seminar dan ruang kuliah umum sebagai bentuk pengabdian kepada masyarakat, berpartisipasi aktif dan melakukan penyuluhan instalasi listrik rumah tangga yang aman, aktif dalam membangun infrastruktur. Kalau bisa Bogor, nanti bisa lagi bersesuaian internasional. Gelar Innovation Research for Science, Technology, and Culture (IRSTC 2019). Selain itu, Fakultas Teknik Universitas Pancasila juga memiliki satu program studi magister teknik mesin. Program studi yang terletak di Jalan Borobudur, Menteng, Jakarta Pusat ini memiliki beberapa ruangan fungsional, di antaranya dan MT, dan beberapa ruang lab komputer. Fakultas Teknik terdapat beberapa ruang tentang keorganisasian, ruang dekan, wakil dekan 1, ruang wakil dekan 2, ruang wakil dekan 3. Fakultas Teknik juga memiliki beberapa ruang fungsional lain, di antaranya adalah ruang rapat fakultas, ruang administrasi umum dan komandan, ruang akademik, ruang satuan jaminan mutu, ruang pusat pengolahan data, ruang humas dan kemahasiswaan, ruang lembaga penelitian dan pengabdian kepada masyarakat, ruang pusdek. Fakultas Teknik memiliki 7 pusat kajian serta didukung oleh kantor internasional. Ruang perpustakaan fakultas yang luas dan nyaman, tersedianya buku, baik dalam bentuk textbook maupun digital e-book. Juga terdapat ruang kecil sebagai ruang diskusi, fasilitas aula yang berfungsi sebagai ruang kuliah umum atau seminar-seminar. Kemudian, dengan kapasitas 6 orang, didesain dengan sentuhan bergaya teater, dilengkapi fasilitas studio audio visual dan sarana multimedia penunjang lainnya. Selain itu, terdapat beberapa keunggulan fasilitas umum yang dimiliki oleh Universitas Pancasila.
Iya, Pak. Fans. Ya.
Pusat pengembangan kewirausahaan dan layanan karir mahasiswa. Tenaga bahasa, gedung serbaguna, masjid yang bersih dan luas. Bekerjasama dengan Bank Mandiri dan Bank BNI, layanan anjungan tunai mandiri, pusat kegiatan mahasiswa, Pancasila, semua bentuk UKM, sarana seni dan olahraga, apotik,
Ya.
kantin, dan hotel. Universitas Pancasila terus memegang teguh komitmen dengan memberikan perlindungan kepada masyarakat, pemerintah, dan industri upaya peningkatan daya saing masyarakat di era digitalisasi. Dengan mengedepankan percepatan dan pelayanan yang berbasis pada konsep teknologi, Universitas Pancasila kini terus berkembang dan berinovasi menjadi salah satu perguruan tinggi swasta ternama dan terbaik saat ini dengan akreditasi institusi A. Sejak 5 dekade silam, Universitas Pancasila fakultas terbaik. Salah satu fakultas terbaiknya adalah Fakultas Teknik
sesuai visi Fakultas Teknik Indonesia, yaitu Fakultas Teknik Internasional menjadi pendidikan tinggi teknik unggulan yang memenuhi kebutuhan masyarakat industri menuju persaingan global berdasarkan nilai-nilai luhur Pancasila.
Fakultas Teknik juga memiliki fasilitas ruang terbuka hijau lainnya, seperti taman unik dan asri yang terletak di depan Fakultas Teknik.
Gratis antar sekolah.
Halo.
Lainnya, taman baca dan area diskusi yang terletak di dalam gedung aneks Fakultas Teknik. Fakultas Teknik Universitas Pancasila telah memiliki 6 program studi S1 dan 1 Magister S2, yaitu program studi Teknik Arsitektur, program studi Teknik Sipil, program studi Teknik Mesin, program studi Teknik Informatika, program studi Teknik Elektro, program studi Teknik Industri, program studi Magister Teknik Mesin, program studi Teknik Arsitektur. Program studi ini memiliki fasilitas 2 laboratorium, yaitu Laboratorium Teknologi dan Fisika Bangunan sebagai tempat pelatihan uji kompetensi kelaikan bangunan. Arsitektur. Satu ruangan studio tugas akhir arsitektur. Ruangan studio ini dengan dosen untuk persyaratan kelulusan mahasiswa. Salah satu keunikan dalam prodi teknik arsitektur ini adalah terdapat lorong-lorong unik dengan desain artistik yang merupakan hasil mahasiswa. Prodi teknik arsitektur memiliki ruang sekretariat prodi teknik arsitektur, dosen prodi teknik arsitektur, sederet prestasi kolaborasi studio studi pada arsitek Kpis tahun 2018 di workshop 2020 di Kpis Malaysia. Prestasi dan produk aktual prodi teknik arsitektur antara lain meraih medali emas dari kegiatan paduan suara Indonesia tahun 2015, tahun 2019 meraih medali emas dan perak dan kegiatan International 2019. Hasil karya mahasiswa prodi arsitektur, diantaranya teknologi bangunan, program studi teknik sipil. Program studi ini memiliki fasilitas 5 laboratorium, yaitu Laboratorium Ilmu Ukur Tanah, Laboratorium Mekanika Tanah, Laboratorium Beton, Laboratorium Kekerasan Jalan, Laboratorium Hidrolika, serta memiliki tempat jadi informasi yang menyelenggarakan ruang sekolah SD.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Greetings and good afternoon for all. Our respectable Rector of Universitas Pancasila, Professor Dr. Wahono Sumaryono, Apoteker, our respectable Dean of Engineering Faculty of Universitas Pancasila, Dr. Insinyur Budi Mulyawan Sutisno, IPM. Ladies and gentlemen, attendees of the seminar and invited guests. Let us all give our praise and gratitude to God for our attendance on international webinar, Green Innovation ICT Application in Building, Construction, and Renovation. And I'm Nur Suryaningsi, will be the host of the opening ceremony in this lovely evening. This webinar was organized by the Engineering Faculty of Universitas Pancasila. For a brief moment, we would like to invite you to sing Indonesian National Anthem, Indonesia Raya. Ladies and gentlemen, next session is the report from the head of the Committee of Webinar 2020. Please welcome Professor Dr. Insinyur Dahmir Dahlan, MSc.
Thank you, Honorable Rector of Universitas Pancasila, Professor Dr. Wahono Sumaryono, Dean of Engineering Faculty, Dr. Insinyur Budi M. Suyitno, Vices of Dean, Department Heads of Engineering Faculty, all webinar committee members, especially Dr. Stefan Vance, now still in Vienna, Austria, all guests and participants of this event. We hereby welcome to all of you with our humble greetings. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
May our days in these challenging years full of gratitude, goodness, and happiness as always. we would like to put on a report of today's seminar. Approximately years ago, a group of world scientists and researchers attended our event of International Conference of Science, Technology, and Culture in our campus. But at present days, despite COVID-19 pandemic restricting our physical presence, seminar would still be conducted online through a webinar. In accordance to global technologies leading to a green technology, we think the webinar theme green innovation system also state our university use, mainly conducted by our engineering faculty. The webinar will be held on the weekly event from 3 of November to 27 of November 2020. Respectively, we invited 5 main speakers. First, Dr. Stephen Fens from Korea. Second, Professor Dr. Ing Forster of Applied Science, Berlin, Germany. Fourth, 10 of November. Third, Professor
Mana
Dr.
satu orang doang anjing, mama satu slide anjing.
Manford University, UK, for 70. Fourth, Professor Dr. Arno Smith of TU Delft, Netherlands, for 25 of November. And 5, Dr. Mario Caterino of University of Campania Luigi Vanvitelli, Aversa, Italy, for 27 of November. So we firstly embolden our rector to give a proper greeting and notice to formally open this webinar series. Finally, we sincerely hope that this webinar would inspire the academic community, especially professors, lecturers, and researchers for global research trend, so that the green technology innovation could be flourish in the future. For your information, we note there are 500 participants today, and we also publish this webinar in YouTube broadcast. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Dr. Dahmir Dahlan. Now, welcoming speech from the Dean of Engineering Faculty. Please welcome Dr. Insinyur Budi Mulyawan Suyitno, IPM.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh.
Salam sejahtera untuk kita semua. Salam, Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning. Syukur alhamdulillah, pada kesempatan ini Fakultas Teknik dan Pancasila diberi kehormatan untuk menyelenggarakan International Webinar Series. Dan pada hari ini adalah seri yang pertama dengan topik ICT Application in Building Construction and Renovation. Merupakan salah satu topik dalam tema besar yaitu Green Innovation. Yang saya hormati, Honorable Rector Universitas Pancasila, Distinguished Speaker Dr. Stephen Fens, dan seluruh para peserta webinar internasional ini yang saya hormati dan saya muliakan. Please let me express my sincere gratitude to Dr. Stephen Fens, who will deliver his speech entitled of ICT Application and Building Construction and Renovation. It's really a great honor for me. Welcome you all in this international webinar. Dan untuk selanjutnya, izinkanlah saya menyampaikan dalam bahasa Indonesia untuk para peserta dari Indonesia dan dari Malaysia serta negara-negara lain yang serumpun, bahwa ini merupakan webinar series yang sangat penting. Dari judulnya dengan tema besar Green Innovation, hari ini kita akan disuguhkan oleh Mr. Dr. Stefan Vance, yaitu ICT Application and Building Construction and Renovation. Saya mohon agar para peserta, baik itu dosen, peneliti, mahasiswa, dan observer lainnya, kami persilahkan untuk menyimak baik-baik dan bisa mengajukan pertanyaan-pertanyaan untuk didiskusikan melalui chat yang kami sediakan. Dan tentunya pada Bapak Rektor yang telah mendukung acara ini, kami mengaturkan banyak terima kasih. Pada seluruh partisipan yang lebih dari atau mendekati 500 partisipan, kami mengaturkan banyak terima kasih atas kepercayaan Anda semua. Dan especially to Dr. Stefan Vance, we thank you very much, and I hope you enjoy in this international webinar, and we'll take opportunity to deliver your green innovation in the field of ICT application. Hope you all, the participants, make a great success and fruitful discussion. Thank you. Terima kasih. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh. Thank you, Mr. Budi M. Suyitno, as the Dean of Engineering Faculty. Mr. Dean of Engineering Faculty of Universitas Pancasila is very happy to greet you all to participate in this webinar. And we hope to see you again in another series of this webinar. Thank you, Mr. Dean. Now is the opening speech of the Rector of the Universitas Pancasila, as well as the opening of the webinar. Please welcome Professor Dr. Wahono Sumaryo.
Thank you, Mrs. MC. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk semua, Shalom, Om Swastiastu, Namo Buddhaya, dan salam kebajikan. Distinguished keynote speakers, Professor Vance, Senior Scientist, Vienna University of Technology, Austria, good morning, and thank you very much for your participation. Good morning also to other participants from Europe or other countries that from time being still in the morning currently. Good afternoon, Mr. Dean of Engineering Faculty, Universitas Pancasila, Dr. Budi M. Suyitno. Good afternoon, all college and all participants of the international webinar Green Innovation with today's theme of ICT application in building construction and renovation. I warmly welcome you to this important event as one of the efforts of Pancasila University to promote and achieve the Sustainable Development Goals in 2030 through green innovation. There are 17 goals formulated by the United Nations and agreed upon by 193 nation leaders. From 17 goals, Universitas Pancasila is focused on 6 goals, which are: goal number 4, equitably quality education for everyone, which is reflected in community services carried out by Universitas of Pancasila, such as training provided by lecturers for communities. Universitas Pancasila students teach elementary students in small villages in Bogor Regency. Goal number 6, clean water, which will be achieved by implementing the water-sensitive campus programs, such as reuse and recycle of wastewater, design of rainwater harvesting, reduce water usage by water-saving appliances, encourage the university members to save water and other programs. Goal number 7, clean energy through renewable energy reflected in our research, such as waste and biomass power plant, microhydro, and wind turbine. And goal number 9, industry, innovation, and infrastructure that involves building resilient infrastructure and fostering innovation. This event of Green Innovation webinar, particularly about ICT application in building construction and renovation, is an example of Universitas Pancasila effort to promote SDGs. Goal number 11, sustainable cities and communities through research and service communities by designing and improving sustainable cities and communities quality. And goal number 12, responsible consumption and production reflected on Universitas Pancasila programs to reduce plastic and paper usage. Universitas Pancasila is a member of the Universitas Indonesia Green Metric atau UIGM World University Ranking. In 2019, Universitas Pancasila was ranked as number 29 in national ranking over 70 universities and 451 in international ranking among 780 universities worldwide, coming from 85 countries. As an effective member of UIGM, Pancasila University is continuously improving its quality as a green campus. Awareness of the importance of green environment, green innovation, and SDGs must be implemented in university members' behaviors, research, as well as community services. Hopefully, this international webinar of green innovation discussing on ICT application in building construction and renovation will greatly impact to University Pancasila in improving research and international collaboration. In this opportunity, I would like to thank to Professor Vance for sharing his knowledge and experience in green innovation, and we are looking forward to continuous cooperation and collaboration. Thank you to all participants for joining this internal webinar. I hope you will find the benefit of this event. High appreciation from the committee who have worked very hard to make this event possible. And to start this webinar, allow me to open the event officially. Thank you very much for kind attention and participation. Have a good day with the webinar. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Dr. Wahono Sumaryono. In the next program, let us listen to the presentation from the speakers. We will hand over the event to the webinar moderator, Mr. Iman Paryudi. Please welcome Mr. Iman Paryudi.
Pak MC,
Thank you. Yeah. Thank you, Mr. Nining. Good afternoon, everybody. I'm Iman Paryudi. I'm the moderator in this webinar. This webinar is the first webinar of a series of international webinars held by Faculty of Engineering by Pancasila University, Indonesia.
The theme of this webinar series is Green Innovation. Before I continue, I must inform audiences that you must mute the speaker throughout the webinar. And for asking questions, you can do it by writing your question via chat. In this occasion, the speaker is Dr. Stefan Vance from Technische Universiteit Wien or Vienna University of Technology. Good morning, Dr. Vance.
Hello, everybody.
Okay. How are you?
Hi. Hello, everybody.
Yeah, hello. Good morning. Good morning, Dr.
Good morning.
Vance.
I can
How are
hear
you? Yeah, how are you?
I'm fine, and you?
Okay, yeah, I'm good too. Even good.
Nice to see
Okay.
you here again.
Yeah, yeah. And we, Faculty of Engineering, would like to thank you for taking your valuable time for us.
It's a pleasure. Thank you very much
Okay.
for the invitation.
Okay, yes. And before we continue, I would like to read Dr. Vance's curriculum vitae. Dr. Vance, Dr. Stefan Vance, CISSP, is a co-founder and managing partner at Silem Technologies GmbH, senior scientist at Vienna University of Technology, and key researchers at SBA Research. From 2012 to 2015, he was an appointed member of the European Network and Information Security Agencies, or ENISA, Permanent Stakeholder Group. In 2010, he worked as a visiting scholar at Stanford Center for Biomedical Informatics Research at Stanford University, USA. From 2008 and to 2012, he lectured on information security at Peking University, Beijing, China, and also in Beijing Jiatong University, Beijing, China, Konkuk University, Seoul, Korea, and University of Applied Sciences Technikum, Vienna, Austria. And he did his PhD Computer Science at Vienna University Technology at 2008. Before we continue to the presentation, I would like to first explain what will be the topic of Dr. Vance's talk and the reason why we choose it. As we all know that fossil energy is not renewable, hence saving energy as much as possible must become a concern. Humans consume energy to power private homes as well as public buildings. As the human population increases, the quantity and size of building also increases. Buildings have now become one of the biggest fuel consumers worldwide. In the US, 40% of the total energy is consumed by buildings. A similar amount of energy consumption by buildings can be observed in Europe, where such energy consumption is 40% of the total energy consumption. Meanwhile, in the UAE, building energy consumption comprises 70% of total energy consumption. The problem of excessive energy consumption by buildings can also be observed in Indonesia. Here, about 40% of the total electricity consumption is consumed by buildings. Another problem with energy consumption by building is that it contributes about 40% of all human-produced CO2 emissions. The increase of CO2 emission caused by building operation is another compelling reason to reduce the energy consumption by building. In order to lower their energy consumption and the related CO2 emission, the European Parliament issued Directive number 2002/91 precise issue. According to this directive, EU member states are obliged to issue regulation that requires developers to calculate building eligibility performance prior to erection. Only building whose energy performance complies with the regulation may be built. The energy efficient buildings are categorized as green buildings. Like European countries, Indonesia also need to take action to reduce this high energy consumption. The Indonesian government, through its standardization agency, has issued several standards for energy efficient building on green buildings. In order to achieve this, energy simulation tools to aid in designing green buildings are needed. That is why, in this occasion, we invite Dr. Vance to talk about such energy simulation tool. Its tool is called Reno DSS or Renovation Decision Support System. As the name implies, the tool is for redesigning existing building. The most important advantage of this tool is that it can generate energy efficient renovation design. In other words, after the renovation, the new building is a green building. And the topic on green building is in line with our international webinar series theme, that is green innovation. Well, that is introduction for me, and I would like to remind the audiences that you can ask questions by writing your questions via chat. Now, it's time for me to invite Dr. Vance to deliver his talk entitled ICT Application in Building Construction and Renovation. Dr. Vance, time is yours.
Thank you very much for this introduction, Iman. And I very much appreciate your invitation to this webinar series. It's an honor to speak here in front of so many people. Didn't expect these high participation numbers. And today I'm happy to show you the latest research results of one of our EU projects. I would like to give you a short introduction and then show you through a live demo. It's really a live demo, so I have also prepared backup slides in case the live system is not working. Forgive me any technical difficulties if they arise, but I would like to make it a little bit more interesting by showing it live to you. So I will start to share my screen with you so that you can see my presentation. Can you see the presentation? Okay, everything is fine. Yes. So the project we are working on is called BIMA. It's an H2020 project financed by the European Union. We are working here with several European partners together to deliver the next generation renovation decision support systems. This ranges from approaches like scan to BIM, but also monitoring the occupants' behavior. One part of this project is Reno DSS, where we work with other partners on the development of such a system and the deployment of the system. Iman introduced me already, so my background is information security and decision support. I did my PhD in 2008. I'm with the University of Technology in Vienna and SBA Research since 2006. I'm also managing director at Xylem Technologies since 2009, where we try to commercialize research results from projects we are doing. And why the topic is important, we also heard it today. I maybe want to give you a little bit of the European perspective. So recently the European Green Deal was done. The plan is to make Europe the first climate neutral continent with no net emissions of greenhouse gases by 2050, which is a quite ambitious plan, which will take a lot of effort, but the direction is clear for the continent. And when you look at the numbers, you will see that energy consumed by buildings has quite a large portion of the energy we use here for heating, cooling, and this kind of stuff. So one key initiative was to increase the renovation rate of buildings in Europe to support the energy efficiency here and the European Green Deal objectives. And the thing here is in Europe with the renovation of buildings is that the rate is quite low, so it's around 1 to 2%, depending on the region in Europe. So therefore, you can imagine that it would take 100 or 50 years to refurbish all the buildings which are currently in the building stock. And the European Commission says this should go, and also the national governments should say this should go quicker or faster. So we have to increase the renovation rate of buildings to achieve our goals. And one problem at renovating buildings is that it's a very complex project. So every building is different. So you need a lot of experts for looking into these buildings and finding out the most efficient renovation measure combination for this building. So what our goal was with Reno DSS is to put forward an intuitive and BIM-based interface which shows you the renovation options for this specific building and evaluates the impact of the building performance and guides you through the alternatives. Because as you can imagine, there is not only one solution, so it's not only one way of how to renovate a building. Instead, there is a large number of different combinations, like you can do an insulation of walls, you can do a new heating system, a new cooling system, you can insulate the roof, but you can also refurbish the hot water production system in the building, you know. So there's a lot of variety here, which makes it complicated. At the same time, we have the luck that BIM, so building information models, are on the rise. So more and more BIM models are used. BIM is like a model of the building where you can store and model all the building, how the building is built, what kind of technology is inside, and you know, you can put a lot of data into the BIM models in order to store them in a standardized way and edit them with third-party tools as you like. So the thing is that Reno DSS is a renovation decision support system. So it should guide you through different options of renovating the building. The important key facts here is this is completely based on BIM. So as input, we take BIM models, more specific IFC files, in order to load the building and identify areas of renovations, and also to calculate different combination of renovation measures. The second key point is that we automatically generate renovation designs. So what we are doing is we take the IFC file of the current building and modify it a large number of times to represent potential renovation scenarios. And for each renovation scenario, we calculate financial, technical, and sustainability KPIs in order to compare the renovation scenarios to each other. We give visual feedback on the designs. It's not implemented yet, but it's a plan to do this. And we enable then with a decision support system the user to identify the renovation design which meets most of the target KPIs. So there is not the best renovation design, but there are several good ones, and the user has to identify the most suitable ones to their needs. So here I quickly outline so that we have written it somewhere the approach of how we are doing it. So as I said, we take an IFC file as an input for the current building configuration. So this IFC file contains all the information we need, like what kind of geometry the building has, what are the materials of the building components, what kind of layers we have in the wall, and so on and so forth. Then we calculate the status quo of the building. So how is the energy performance right now? How is the LC, LCC now? And then the user sets target KPIs. So he says, for example, he wants that the building consumes only that amount of energy in the future. And what we do then is we generate automatically potential renovation designs by combining the measures. As measures, we have insulation, new windows, PV, heating system, solar collectors, and so on. And then we calculate for each of these designs the KPIs, and the user can select the most suitable to him. On this point, I have the live demo. I will now switch my screen to, let's see how this works, to my browser. So do you see my browser?
Yes.
Yes, it's clear.
Okay, browser. Okay, perfect. Perfect. Thank you for the feedback. So This is Reno.ss, so it's a web-based system, as you can see. The nice thing about the web-based system is that you can collaborate, so that you can like have projects on it and everybody joins the project from the browser. As I said, this is work in progress, so this is not a finalized product. This is the latest deployment we are currently having in our research project, so please excuse any errors or anything else. Things you see which are not nice. It's not finalized, as I say. So, and the first thing is that you see on the right-hand side here the projects. The projects are loaded from an interoperability layer of the entire consortium. So we get them already from another component of the system architecture, and we simply show them on a map here. So where the construction sites are. We have 2 pilot buildings in the project. So one is in Poland and one is in Spain. With these pilot sites, we will test our research results. So they will renovate this kind of buildings for real. So they are really renovating these buildings. It's 2 social housing buildings, depending on and we'll use the tools which are developed in the BIMA project to support this renovation project. So then I click on one project, it's the Spanish one. And as you can see on the right-hand side, the system already extracts information about this building from the IFC file. So like the wall areas and the usable floor areas and the height, they are extracted already from the IFC file. So we are not putting any data manually in. We are extracting from the IFC file. Here you can see where the building is located. So it's just to give you an impression where this is. And then it already starts on the bottom here with the data we need for calculation. I told you we are also calculating life cycle assessment KPIs and life cycle cost KPIs. So how much is the building in its entire lifetime? And therefore we need a few parameters like what's the period of analysis, discount rates, escalation rates for maintenance costs, and also end of life costs. These are different inflation rates we can set for different things. And then we have the energy prices, which are also important, of course. So we have to know how much is a kilowatt hour gas or district heating and how much it will grow in future and what's the CO2 emission rate of this, because we need these figures in order to tell the people if you choose this, for example, this configuration of renovation, it will result in this CO2 emission rate and this. And this, of course, depends on the energy carrier which you're using. And as a last one, we have the environmental costs. We are also providing KPIs for sustainability for sustainability issues. And there we have different categories of sustainability criteria, like acidification potential. And for each of them, we assign monetary units to one unit of this. So for that you can, like, the goal is that you say this solution has environmental costs X compared to the other solution which has environmental costs Y. And to calculate this, you of course you have to put a price on this environmental indicator. So you have here the prices for this. You can change this for every project, of course, because it will differ if you are in Poland or Spain or Indonesia. There are different, of course, there are also different energy prices. So you can set all these numbers for this specific project. So they are not fixed. They are default values, but you can also provide your own numbers. And that's for this screen. So this is called the base data. This is what we have here right now. And then we have another feature which is called urban planning. In the urban planning, what we can do, this is our building which we have currently in scope. And here we can say the main goal of the urban planning is that you not only look at the building by itself, but that you also take into account the surrounding buildings. As an example, so you might look at this building and you say, because nobody is living there during the day, it doesn't pay off to put a PV installation on the roof here, right? Because nobody's living there, so we don't consume any energy, so it doesn't pay off to put PV on the roof here. But if you take a step back and look at the district here, you might discover that, for example, at this building, there are people living during the day, like it's an office building, and it already has PV on the roof. But from a bigger perspective, it would also make sense to equip this building with PV so that the power which is generated on this flows into this building and supplies this building with energy. And by doing this, you somehow de-stress the grid here, yeah, right? Because if you produce the energy locally, you are not stressing the power grid here that much. So
Dr. Fans, may I interrupt?
Yes, please.
I'm afraid that your slide is not moving.
You cannot see my.
Yeah, only the first one. Only the first slide.
You don't see my browser?
No. Yeah,
Okay,
only the first one.
Let's do it again. Thank you for interrupting me. Do you see it now?
Yeah, difference. Okay.
Okay. Have you seen the previous one also or not?
No. Try to move forward.
Yes, sir.
Okay, now you see a different screen, right?
Yes.
Okay.
Yeah.
So you didn't see the screen I have explained before, so I will repeat.
Okay, thank you.
Because this is I go over it quickly. So, sorry.
Okay,
so
thank
this
you.
is the screen where you enter.
Yes.
And then you can select here the project on the right hand side, and then the base data loads. And as I explained, this data here is extracted from the IFC file. And on the bottom here is what I've previously explained regarding all these values we need for the life cycle analysis, like the analysis periods and rates. Then the energy prices, which you can set for your project, and then the environmental costs you can also set for your projects. So I will proceed to the urban planning, and this is what I explained regarding the urban planning. So we have a map. Here's the building, which is under renovation. And I explained that we can now enter here data about buildings which surround this building, like this one, in order to tell the system how this building is used. So like it's 80% residential and 20% office, and how much the consumption of this building and production numbers are. And we have here plenty of options. So we can either upload a default load profile for a usage type, or we can upload concrete load profile with absolute or percentage values. So, you know, with the distribution of smart meters, a lot of buildings have very detailed load profiles regarding their production and consumption figures. And we can use this data in this screen to tell the system how much this building, for example, this here, produces and consumes energy. And this data we use to calculate the urban planning KPIs, which is basically how much energy is going from our building to the district and how much energy is flowing back. This is an important figure in order to optimize the renovation action on this building to make sense or to benefit the entire district here. Yes. So, and when we go to the next screen, we see the KPIs, and these KPIs have already been calculated. So we have 4 different categories of KPIs. We have economic KPIs, we have sustainability KPIs, energy KPIs, and comfort KPIs. Each of these categories, you will get a figure for the status quo. So we can also switch here to all KPIs. So we are calculating quite a lot of them. So we have here the KPIs of the status quo, and we can set target KPIs. This is what I meant before, so that we can somehow say, okay, currently the primary energy consumption of this building is 65 kilowatt hours per square meter per year. But we would be able to say here, okay, I would like to achieve 40 in order to increase the energy efficiency of the building. And what the system does afterwards is to exclude all the options which are above 40 in this specific KPI. But you can also set the target KPIs like in any KPI, as I said. And this just gives you an impression of how the current building configuration is performing currently. And then you can tell the system, okay, your wishes, let's say, and let's say, okay, I want to have this kind of energy performance only in my renovation options. And that's it. So now we are going already to the renovation measures, which you can see here. They are quite complex, so let me explain. In general, we can set measures in these categories: facade, roof, floor, fenestration, which means windows and doors, lighting, heating system, hot water, solar, and cooling system. So in each of these categories, we can improve or renovate the building in order to achieve a better building energy performance and sustainability performance. So what the system is doing, it passes the IFC file and identifies building elements which fall under these categories. For example, in case of facade, it found two external walls, groups of external walls, because the concrete external walls we see here, these belong to this group. In the case of the roof, it found one external roof. Case of floor, it also found a floor, And now you can tell the system for each group, it tells you how the current layers of this wall are. So for example, this wall here, this external wall, has just a wall board, a concrete layer, which is 18 centimeters thick, and a wall board again. You have to tell the system what is the condition side. So what is the warm side? Is it this one or this one? So you can switch here in this case. And on the right-hand side, you can then define what kind of renovation measures we can apply on this wall. Like here, for example, these are already default. These are set by the system, so you can either insulate the wall from the outside, so an external thermal insulation system, or you can insulate it from the inside, an internal thermal insulation system. And each of these measures, as you see here, has different layers assigned. So for example, if I would like to insulate on the outside, I have to have this adhesive, then I have an insulation layer, and then a plaster. If I want to do it on the inside, it's a little bit more complicated. I would have this layer, then I have an insulation layer. Here, for example, you can see that if you have two different ones, they share the same position, but different thickness. So this means that you can choose one of them. So you can insulate with 5 centimeters or 10 centimeters. And then you need this vapor break and then a board again. These configurations you are seeing here are already set by the system. So an administrator can change them and enrich them and extend them. But the normal user doesn't have to specify it. It's already per default provided here to the user. What you can do, of course, you can change the layers. So you can remove them, you can add one, but you can also change them. So you can say, in my project, we don't have material costs of 20, we just have 10, or we have different installation costs, different maintenance costs, or different disposal costs. So you can change all of these values for your specific project, and you can either change the materials here. These materials are coming from a component and material database we established. So you can select here also different materials of insulation materials. So like here you have the different kinds of like Yes, and then you have up here like mineral insulation materials, like mineral foam or wool or wood chips, whatever you like. So you can define here by yourself what kind of insulation materials you would like to have in this building project. And of course, you can define as here for one layer alternatives. So you can say wood or yes or whatever. And this, the user can specify this here in detail, or the user can simply use the default ones and go ahead. And the same you do for the roof. You see here we have more than 2 renovation measures. So you have flat roof insulations, pitched roof insulations, and so on and so forth. So you have a lot of default renovation measures, and you can check here what kind of renovation measures are relevant for your project. At the windows, it's a little bit different. So we have here the windows from the IFC file, and then we have here not layers and constructions. We have just different components. So you can say, okay, these are my windows in this building, and I would like to renovate them with triple insulating glass, but you can also say with double glazing. So it's up to you what you would like to include in your renovation scenarios. So the lightings are currently not there. The heating system, you see, this has still to be done. These are the components which are where we are currently investigating of how to save this data in the IFC file. This is just the thing what we are doing this week and next week to look how we can store this information in the IFC file regarding the heating system and lighting, the constructions and the thermal hull we already have. So when you have set all of this, you go to the renovation scenarios, and here you will be presented a screen where each line of this is a solution, so a renovation scenario. So think of each line as one option to renovate this building. These values are currently mocked values, so they're not real. Therefore, you see here all 1, 1, 1 and different awkward numbers, because this is also something we are currently working on, that we are here getting the numbers for each scenario. So right now we are building the scenario generator. This is what we are doing right now. And because this is not finished yet, we have here just mocked numbers, but it gives you an impression of how the end result will look like. So this assumes that all the scenarios have been built and all the KPIs have been calculated. And then you will see here for each scenario one line. And these are the KPIs. So like this, the life cycle cost, payback period, construction cost, and then you have the sustainability KPIs like the environmental cost indicator I showed before. And here you can then sort these things, because you can say, okay, I want to have these solutions which have the lowest life cycle cost. But you can also filter here. With these filters, you can filter the solutions on this side. And these are also the most relevant KPIs. You can show also all of the KPIs, so then it's a little bit more. As you can see here, then you have lots of KPIs, but we are trying to filter them to not overwhelm the user. And when you click on one, in the end, you will have here the renovation measures, where you can see then what kind of measures exactly have to be implemented in order to implement this renovation scenario. Here you will see the measure category, the type, like here facade, and you will also see the quantity and some selected KPIs here, so that you can see on one hand at one glance how much you have to do, how much it is, and what your expected work effort is in this case. And this is almost the last screen of this system. So this is the decision support system, where you select the most suitable renovation measure for your measure combination for your project. And in the end, you will also have the opportunity or the possibility to generate a PDF report out of it. so that you have everything in a PDF report, which you can hand them then to a planner or to a construction company to investigate this in more detail. And yes, and also what we are doing, also we are generating for each of these solutions, there will be an IFC file, so that you can download the IFC file with the renovation measures already implemented IFC file, so that you can use it to further edit it in tools like Revit or ArchiCAD or similar BIM tools. And what we will also offer in the end, but we are still working also on this, is a visualization of the building in this system, so that you can see maybe a comparison between the current status and then the refurbished status, so that you can have a visual feedback of what is done. This is also not here now, this is also ongoing work, what we will do here. So, oh, sorry, this is the, so what is the benefit of this system? So currently, renovation designs are mostly done manually with tool support. So what you are currently doing, you have experts who are really experts on their field, and they have a good feeling about a building and what should be changed in order to get the most out of it. Then they calculate their ideas with traditional tools to see how the numbers are turning up, like Energy Plus and this kind of stuff. The problems associated with this approach is that the renovation designs are, of course, dependent on the experts who configure them and also on their experience. And you can only do a limited number of renovation designs because of time constraints. You know, you cannot do thousands of it because it's just too much work to do this manually. And from this follows that optimal renovation design might be overlooked by the expert. So I'm not saying that the expert is doing a bad job, they are doing a wonderful and great job, but you know, because of the large number of different renovation scenario designs, it might be the case that some better option is overlooked. So what we are doing in Reno DSS, we are somehow configuring the renovation designs automatically based on internal rule sets, and which tell us how the measures can be combined. This, of course, then enables us to generate and calculate a large number of renovation designs. So it's not only a matter of computation power and time that you go through all of them. Not all of them, but through a large number, because it would be too large in most cases. And then, based on this large number we have calculated, the user can then select the most suitable one. As I have shown with the sliders, with the sorting algorithms, they can go through and select the most suitable one. I'm not saying that there is the best or the only one option. It's always dependent on the preferences of the user and on the configuration, what's the most suitable. So therefore, we are not providing you with just one solution, which we think is the best, but we are providing you with many and tools where you can select them out of this scenario pool. So this is the end of my presentation. Thank you very much for your attention, and I'm happy to take your questions. I've seen a lot of chat messages, but I was not able to look at them during my presentation. So maybe you can ask your questions now or as you like. Thank you very much.
Thank you, Dr. Fan, for the presentation. Before I summarize what has been explained by Dr. Fans, I remind again that participants that you all can ask questions by writing your question via chat.
Okay.
Well, as I mentioned earlier, that basically this presentation talk about features in Reno DSS tool, namely BIM integration, automated generation of renovation design, provide financial, technical, and sustainability KPIs for each renovation design, visual feedback on renovation design, and enable the users to identify the renovation design which meets all or most target KPIs. Now we come to the question and answer question. Let me see the chat. Maybe there's question for Dr. Vance. Well, I don't think there's a question for you, Dr. Vance. So let me ask you a question, Dr. Vance. By the way, can we use this tool in tropical countries like Indonesia?
Yes. So currently the tool is built for the European environment, but it's no big deal to adapt it to other regions of the world. What has to be changed here, of course, is the materials and components we are having in our database. Of course, they would have to be adapted to Indonesian materials and components. And the other thing is that we have also weather data files which we are using for the energy simulation, but I'm pretty sure that these weather data files are also available for Indonesia. So there is not much to do in order to adapt the tool for other regions of the world. As I said, the most prominent thing is the material and component database, because the materials are of course different and also the components are different. But from the measures, we have, as I said, our goal is also to include cooling systems, which are important for Indonesia, but also the wall and the thermal hull in general of the building should be easily adaptable to Indonesia.
Okay. What about the formula? Is it difference between formula to be used in European countries and in Indonesia?
Yes, thank you for the question. Yes, in previous projects it was a difference, like we worked together on them. But now what we are doing, we are using Energy Plus, or our partner Hypertech from Greece uses Energy Plus for the energy simulation of the building. So Energy Plus is doing a very fine-grained energy simulation of the building. So it doesn't matter in which area of the world we are doing this, it's the same calculation mechanism. So we are not longer we are not longer using national calculation standards, but we are using now international ones, in this case Energy Plus.
Okay, thank you. Wait. Okay. Next question. In order to recommend new designs, you need to carry out optimization. And the goal of this optimization is to find alternative design that are better than the initial user design in terms of maybe heating demands or inverter costs or environmental impact. So my question is, how did you do this optimization and what kind of technique did you use?
Yes, so we optimize not really in our system. What we are doing is we are calculating different scenarios and then presenting the results to the user so that the user can choose what's the optimal renovation scenario for them, depending on their preferences. So would they like to have the cheapest one, the most sustainable one, or would they like to have a mixture of both? So we are not optimizing the designs. We are just calculating a big number of them and then providing them to the user so that they can select.
So which design must be select? I mean the small environmental impact or small cost or what?
Yes, so therefore we have KPIs which somehow represent this. So like the life cycle cost. If you take the life cycle cost, it includes a lot of parameters like your heating, the disposal costs, the installation, maintenance costs, and you can also combine them with the sustainability indicators. So you can see how much a building is in its lifetime, and also from the sustainability point of view, and can then say as a user, okay, this is an important KPI for me, so I will choose the configuration, the scenario, also the renovation scenario according to this KPI. But the next one says, okay, I don't care about any of this. I just want to have the one with the lowest construction costs for what reason ever, and so they select this. So we don't prejudge the preferences of the user, but provide them all the data they need to make their decision.
You said that this Reno DSS tool provides many recommendations. So it means that the user must choose by themselves which one they want.
Yes,
is that what you said?
Yes, but it's not that hard because, as I have shown, you have this sorting and filter mechanisms in the user interface, and usually users know what they want. If they go for the lowest life cycle cost, and if they know this already, they just sort it by the lowest life cycle costs on top and choose one of these renovation designs. So they don't actually play around very long with this user interface. They know already what's important for them, and then choose just in this KPI the best or one of the best solutions. But the nice thing is here with this user interface, they can see how the other KPIs are behaving, so they can somehow also compare the solutions in this case.
Okay, let me check the chat first. Dr. Fans has a question. My name is Yolanda Krista Darasti from University of Pancasila, and I would like to ask a question. Based on the last slide of presentation, it said that we can use it for a large amount of any renovation. So, is there a limit amount of it?
What limit? A large amount of renovation.
Yes. Maybe what?
Yes, you're right. Yeah, this is also a great question.
Yeah, my one question.
Yeah. This is also something we are working on. Is I have shown you this categories of renovation categories like facade, roof, and so on. And I've shown you a lot of building elements. You can imagine how many combinations this can be, depending on the size of the building. And if you think that the calculation takes some time, because it's a very accurate simulation of the building, we see that we have to limit this amount. So we cannot, of course, we might buy some cloud computing resources and do that forever, but of course the user also wants to have a feedback in a reasonable amount of time. So what we have to do is, in the end, in the upcoming project, we have to decide what kind of measures and what kind of solutions we should cut off and not follow them, so that we have a smaller amount, that we somehow filter out those solutions from the beginning which does not make sense in any KPI category. And the question is a very good one, because we have to still do this, but we haven't done it because we are not that far in the project. But at some point we have to decide what kind of scenarios we should calculate and which not.
Yes. Continuing this question, because in recommended system field, recommending many items to users is not a good one. that's why the system must limit the recommendation. So I have a suggestion that maybe you can put a feature like so can user can choose the priority. So maybe the priority for energy performance or priority as environment tech or something like that.
Yes, good idea. So we already, as I have shown, we have these target KPIs where the user can enter the target for each KPI. And this is, for example, something we use to limit the amount of solutions we show to the user, because any solution which goes beyond this target KPIs or below or above this target KPI will not be shown. So this is why we had these target KPIs which are showed in one of the screens. Yeah, definitely a point. Yeah, thank you.
Yeah, yeah. You must limit the number of renovation design. So don't let confuse the users.
Yes. We cannot show millions of them. Yes.
Yeah.
A few. Yeah. Totally right. Yeah.
Yeah. Wait. Okay, next question. The first is, I'm so sorry about the accident in Vienna. I will be okay now. The question is, what about the first cost for this innovation? How can be true for the now, the public, and here for, I don't understand.
So the cost of this innovation, I can try to answer. So the cost of this, so now it's a research project, right? So we are developing methods which are innovative to come up with a prototype or something where we can show how it works. So we are away from having it as a product which you can sell on the market, and we still have to think a lot of how to do this and who needs it really. But we are in contact also with cities, not in this project, but just on an informal basis, and large building operators who tell us, yes, there is a need for it, right? Because we are like running hundreds of buildings and we want to refurbish them, but of course we want to refurbish only those which make sense, where we get the most out of our money, and where the occupants have like the best living conditions afterwards. And there's a need for it. So I think that the public value of this tool is that you have something which enables you to do the renovation actions in a smart way, which is positive for the environment. It's positive for occupants because they are having better housing conditions afterwards. And on top, you have it like with low life cycle costs, so that you can inform yourself upfront about the renovation, see all the different possibilities, and then choose wisely the one renovation scenario which you would like to go, and then implement this. So I think the value for the public of this project is manifold. So it comes to the sustainability factor, it comes to the occupant's comfort, it comes to the financial perspective, and of course, also if you think of the environment in terms of CO2 emissions, because we are calculating also these parameters, you immediately see what renovation scenarios have a minimum CO2 impact, like if you get the materials from local resources instead of shipping them around the planet, So I think there's more than one positive impact of this project results.
Okay, next question. Good afternoon, Doctor. Is there any risk of using the system if we are not already familiar with the system? I think this is already explained. Easy. Yeah.
I would say it's not a system. I mean, in the end or in the upcoming project months, we will also include like an interactive manual, so that it explains on the screen where you are, what you can do there, because now it's not self-explaining, but it was not intended to be self-explaining, because it is a tool used by experts, but still you are completely right with this question. Now it's not self-explaining what to do, for example, in the urban planning screen. You have to know it, and therefore one of our tasks for the next weeks or months, better to say, is to find some way of communicating the functionality of each screen in the most easy way to the user. And we have already a few ideas about it, but we still have to do it.
Okay. Next question. May I have the PowerPoint presentation?
Yes, I've sent it, but I can send this again to you.
Okay, yes.
Because I extended it a little bit.
Okay, yes.
I can send you the presentation. Yeah.
Okay, yes, and I will forward it to all audiences.
Yes. Yes.
Okay. And Dr. Stefan, I want to ask you a question. What is your next development in this application, and what impact this application has on the work in the future? Thank you.
So now we are. The project runs, I think, until the end of 2021 and a little bit further. So I think it's in the mid of 2020, 22 when it stops. So this is our goal right now. So we have now until June we have to finish the system as such, and then after June we will integrate it intensively with all the other components in the project, because the project as it is much bigger than Renovation. There are a lot of very good partners working on very good ideas in all kinds of this renovation, and in the end it will all come together and we will have a flow, a process from the beginning. So there's our partner University of Edinburgh, for example, they have a scan to BIM where they have laser scanners and make BIM models out of it, very impressive, which are then the input for our tool to calculate the other stuff. And this will come together. We are doing integration work right now, but we will intensify it after we have finished the Reno DSS. And then we will try to achieve impact with it by showing it, of course, demonstrating it to stakeholders which might use it. And we put very much effort on distributing this work and showing people what we do so that they can also cooperate with us or use it or whatever. So this will be the focus of our work, and I cannot tell you what the next project will be, but I think it's the results we are producing here are the nice basis for extending it to other fields in the renovation domain.
Okay. Next question. Introducing me, Ridwan from Faculty of Engineering, Andalas University. The question is, how important is a country in implementing green buildings?
I think it's very important because on the one hand you have this environmental perspective, but on the other hand you also have the occupant's comfort. So you know that it's not too cold, too hot, or whatever in the building. And the other side is that renovating buildings is very good, because you are empowering the local economy. Because usually it's local construction companies which are coming and renovating with local resources. So you are not sourcing or getting the material and the labor from overseas or somewhere else, but you are employing the local people by doing this construction work. So in a way, if you invest money in refurbishing or building green buildings, you're also supporting your local economy and therefore the local people. So it has a lot of good sides in this way. And I think, as I said in my introductory slide, as buildings are a big portion of the energy consumption in a lot of countries, it makes sense to invest money to reduce this energy consumption and to reduce emissions in order to contribute to UN Sustainable Development Goals or to European Green Deal or whatever initiative there is. I think it's important, and it's a good way of improving the quality of life in various aspects.
Okay. I think the Dean of Faculty of Engineering will ask you a question. Huh? Oh, okay. Yes. No, the next question is, Yang mana? Oh, yes, yes. Yeah. Question is, what are your ICT tools applicable to not only standard building but also not standard ones?
Yes, so they are applicable to any kind of building as long as it's in a valid IFC file. We have some requirements for the IFC file we need, like second level space boundaries so that we can identify the thermal hull of the building. So yes, there are requirements for the IFC file, but only standardized ones. But as long as this is given and the information is in, we are not depending on the type of building, which is also nice. Because we are using standardized IFC files, we are quite flexible here.
As far as I know that this kind of tool can only be used to enclosed building. I mean, no ventilation. So can we use this Renovation tool for ventilated building?
For ventilated building, we don't have inside currently you mean the automated ventilations, so that we don't have ventilation systems in right now as a renovation measure. But as I say, we can use it for you mean ventilated buildings, the traditional Indonesian ones, you mean? I'm not sure about this. I don't know if you can hear me. But we currently have the assumption that we have a thermal hull around the building, which we can isolate. Iman, I lost you. Okay, I'm looking myself for questions. So what is the biggest barrier to implement green buildings in Indonesia? I don't know about that much, but I can talk from Austrian perspective or from a European perspective. The barrier is most of the time the investment case, so that you say you invest money in this renovation of the building, and it doesn't pay off in the end because renters are not paying more rent, or therefore, in Austria or Europe, there are a lot of funding programs which are like funding the renovation option, as the renovation of buildings, so to make it more attractive as an investment case. So that's, I think, is the main barrier. Yeah, it's mostly about the money. Therefore, these kind of tools are important to show that the renovation also can be an investment case, so that it pays off, especially in times of very little interest rates all over the globe, that you can invest in your buildings and actually earn money with it by lowering your energy costs in the end. So the next question would be if the building considers fire resistance. No, it's not in there, so we don't have a check for these regulations also how fire resistant.
Yeah, the next question is
the fire resistance was one question.
Yeah, what are the biggest? What is the biggest barrier to implement green buildings in Indonesia?
Yeah, I answered the question right now. So I said that that I think I cannot talk about Indonesia that much, but I can talk about Austria and Europe, and the other problem is the investment case, so that it doesn't pay off to invest in a renovation. Therefore, we have funding programs from government, and I also said that therefore it's important to have these kind of tools to show people that it might pay off to renovate the building. Especially in times of low interest rates on the capital market.
Okay. The next question is, could you give us the exam grid build? Do you understand?
No, therefore I was not answering. But what do you mean?
Okay. Now,
example.
Example maybe.
Example, yeah.
Example of green building, yeah, maybe. Can
Yes,
you
yes.
give the
So
example of green buildings?
Yeah, I can only talk about my local experience here. So what they do here right now is, of course, to insulate the buildings, to use heat pumps in order to have no emissions when heating the building, or using district heating networks. But the latest trend, let's say, is the green facades, so that they have plants on the facades and the roof in order to support the cooling of the building in summer, and also to make the city more green, which is, I think, a nice idea, because of course it's a lot of work to have a facade green, but this is one of the latest initiatives in the city of Vienna, for example, I've seen. This goes together with the gardening trends and, with the heat islands, so that you cool down the city by having more plants in the city, and therefore they're using the walls and the roofs of the building in order to make it more green. I think it's a very good initiative. This is what they are like trying out now, because we are having, especially in Vienna, we also have hot days in summer, and air conditioning is not very distributed here, so not a lot of people have air conditioning here. So they're trying to use passive cooling techniques in order to cool down the entire city, and therefore they use like plants and this kind of stuff.
Okay, next question is, does green building consider the resistance? Is it integrated with IBC or International Building Code?
As I said, no, we don't consider this fire resistant. So we only focus on the energy consumption of the building and on the renovation options, which can help to reduce this energy consumption or increase the comfort of the occupant.
Okay. Next question. Sir, I have a question. The green building run on heat to generate power, so they are not designed for hot areas, as they do not have any ventilation system. So
Yes.
air conditioners will be required, which will make this building anything but eco-friendly. How about the solution? Thank you.
This is what I said before. So of course, air conditioning is like the worst cooling technique, because it, as you said correctly, it uses a lot of energy to do this. So therefore, there are other measures we can take, like having green facades, green roofs, but also using not thermal, but how to say in English, cooling down the building elements by cooling the core, like pumping cool water through the concrete parts of the building to cool the entire building construction down, which is much more energy efficient than using air conditioning systems. Shadowing, so shading is also a thing, like having trees and other stuff to cool down the environment. Or district cooling is also something which is done in Vienna. So yes, you're right, the air conditioning doesn't make it friendly, and therefore a lot of other techniques are used to cool down the buildings here. Because as I said, summers are getting hotter and hotter, so people are looking for options to also have nice temperatures in their building, even if it's hot outside.
Okay, next question is, I think this is the last question. Yes, this is the last question. How much the price per square meter for this ICT renovation green innovation?
I cannot tell you exactly how much the renovation options we are calculating right now are, because now we have demo data in it. So with the price, the cost data we have right now, I have shown is demo data, so it's not real data. I might be able to answer this question when we run the pilot sites in the project, because then the partners which are actually refurbing the buildings there will provide us with data, with cost data for all these measures, and then we can say something about the price per square meter, but I cannot answer now, especially because it very heavily it depends on what you implement as a renovation measure. But good question, thank you.
Okay, I think that's the last question from Adrian, and I think this is the last question from me. As you know that if we want to have a good building, a green building, for example, the energy, small energy performance or good environmental impact, you must have good quality materials. But having the good materials, you must invent more money in that building. So there are contradict target in here. So my question is how do you solve this multi-objective optimization?
Yeah, so we solve it by having the, if you compare the cost of the building to the energy impact, you can also, if you take into account, so if you put all together, like in the life cycle cost, and you also using a life cycle cost, per definition, there are the energy costs inside, the construction cost, the maintenance cost, so we have everything in one number. So you can then choose those where the life cycle costs are the lowest. And if you combine this with the sustainability indicators, you can make an informed decision here. But I get your point, but we don't do multi-objective decision support at this point. What we do is we have this sorting and filtering mechanism so that the user can filter out solutions they don't want. And because we don't want to prejudge the user, so we don't want to take away decisions from them, but we want to try that they see what options they have and can choose by themselves what to choose. And one method of this is using the LCA approach, so the life cycle costs, and also including sustainability's environmental cost indicators in order to represent the thing what you have said. Because you are totally right. Of course, you have like investment costs and energy consumption, and these are, the lower you invest, the more energy we use. You are totally right. But we try to cover this topic by using life cycle cost approach.
Okay, I think there is another one question. What percentage of electricity must come from renewable energy so that building can be set green?
I don't know about the exact definitions. When it's green, I mean, there are a lot of standards out there where you can certify your building against, and they say, okay, you only need 100% renewable energy sources and so on. I cannot answer this right now, but I would say if you refurbish a building and it has a better energy performance than before and better occupant comfort, I think it's a success. And no matter how you refurbish it, of course, you should aim for the biggest energy efficiency, but even if it's a small improvement, it's an improvement and helps to save energy in the long run and makes the life, I think, of all the people living there better. Because, lower pollution, lower costs, and you can use the energy better for something else.
Okay, thank you, Dr. Vance. I think time is up, and it's time for me to end this webinar. On behalf of Faculty of Engineering, Universitas Pancasila, I would like to say thank you very much to you to share the valuable knowledge to every one of us. And I hope this is not the last one. Maybe I hope we can meet again in the next webinar. And I also would like to thank you to all audience. Thank you for joining this webinar. And I also hope that we can see you again in the next webinar. So,
Mr. Iman.
in the end, I am Iman Pariudi, and goodbye. Back to you, Mrs. Nining.
Thank you, Pak Iman. With the end of this question and answer session, we have reached to the end of our program today. But before we close today's webinar, we would like to remind you that this webinar is a series of webinars that will be held on November 10, 17, 25, and 27 with different themes for each series. And the e-flyer for the future webinars will be shared soon. And we would like to apologize if there is deficiencies in this program. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Good evening.
Thank you very much.
Waalaikumsalam warahmatullahi
Nice day.
wabarakatuh.
Bye.
Thank you, sir.
Bye. Goodbye, Mr.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you all.
Thank you for the presentation.
Okay, now is photo session. Before we leave, there is a photo session.
Is Mr. Stephen? Where?
Lungo, Bu.
The photo sip.
Halo. Halo Bu Sri. Halo Bu Sri. Halo Bu Nining. Is it good? Is it good? Was it good? Bu Sri main di mute. Bu Sri sama Bu Nining tadi di mute.
Ya. Mr. Stephen-nya mana?
Apa?
Lungo, Bu.
Wes mule, wes lungo.
Aja lu ganteng jelae. Congratulations, Tim. Bye-bye.
Thank you.
Thank you.
Bu, besok Alpro, Bu.
Thank you.
Halo Pak Jafir.
Sip. Thank you.
Terima kasih. Terima kasih.
Ya.
Terima kasih.
Oh ya, oke.
Ya, Bu Sri. Ya.
Mohon izin. Udah selesai kan acara tadi semuanya.